Problem 1. A distortionless line has parameters R equals to 4 ohm per meter and G equals to 4 into 10 power minus 4 Siemens per meter. The attenuation constant and the characteristic impedance of the transmission line will be respectively. Options are given as A. 25 Napier per meter 0.01 ohms, B. 100 Napier per meter 4 into 10 power minus 2 ohms, C. 4 into 10 power minus 2 Napier per meter 100 ohms, and option D is 0.01 Napier per meter 25 ohms. Just observe the solution. So here the type of transmission line which is given to us is a distortionless line. Always what you do is just to try to remember the basic conditions and basic formulae. Don't go for remembering all those equations. Just to remember the basic formulae and some of the conditions which are useful for a distortionless line, lossless line, open circuit line, like that. Right? Here the type of transmission line which is given to us is a distortionless line. Now for a distortionless line, what is the condition? R by L is equals to Z by C. So R by L is equals to G by C is only the condition for distortionless line. Remember that one. Now R is given, G is given, we are supposed to calculate alpha and Z naught. Once again I am saying don't remember the formula for alpha and Z naught. Just remember the formula for gamma and Z naught as their own or original formula. What is the formula for gamma? Here I am writing the formula for gamma. Gamma is equals to square root of R plus J omega L multiplied with G plus J omega C. Now take L common from this term and C common from this term. Then what you will get here is R by L plus J omega. L will be there, right? Here also it is G by C plus J omega and L into C. As R by L is equals to Z by C, so these two are same. So from root you can bring them out. R by L plus J omega I am considering instead of G by C, root LC. That's what we have here. So which is nothing but gamma. Now equate the real part to alpha and imaginary part to our beta. Here what we require is just alpha. So take the real part. What is the real part? Alpha is equals to R by L root LC. That's what we have. R by L root LC. Now I want to simplify this particular term. Then it will becomes R root LC by L square. L will be cancelled, which is equals to R root C by L. Right? Now what is C by L? Just rearrange this particular term. R by L is equals to G by T corresponds to R by G is equals to L by C. R by L is equals to G by C. Instead of C by L, I can substitute G by R. Here instead of C by L, I will substitute G by R. That is R root G by R, which is equals to square root of R square G by R, just which is equals to square root of R G. That what you have to do is just I used a little bit lengthy method, but immediately you can modify all these equations within your mind. Don't go for all these equations and don't put them on paper, right? Simply root RG is the value of our alpha. It's not gamma, alpha, right? Similarly Z naught we require. So Z naught is equals to root L by C. Directly you can remember that one, no problem. The same equation is useful for either a distortionless line or lossless line. Root L by C means root R by G. Root R by G. So with the help of just R and G you can calculate alpha and Z naught. No problem. Now what is alpha? Substitute there. Alpha is equals to root RG. What is R here? 4 into what is Z? 4 into 10 power minus 4. So which is equals to just 4 into 10 power minus 2, since it is alpha, Napier per meter are the units. So 4 into 10 power minus 2 Napier per meter. And Z naught is equals to root R by Z. What is R here? 4 divided by what is Z here? 4 into 10 power minus 4, just it is 10 power 200 ohms. So easily you can obtain these two parameters alpha and Z naught. So these two options are wherever these two options are available, just you put a tick mark or bubble it. This is the answer for our problem. Problem 2. A purely resistance load ZL is connected to a 150 ohm lossless transmission line such that it has a voltage standing wave ratio of 3. the possible value of ZL will be. Options are given like this. Option A 50 ohms, option B 450 ohms, option C both A and B, and option D none of the above. Now just you observe what is the data given to us. A purely resistive load was connected to a line with a characteristic impedance 150 ohms and the standing wave ratio is observed as just 3. Now you need to calculate the possible values of ZL. So you need to correlate them. Already we have a wonderful equation for that one. That just try to get the equation for gamma first. Gamma is equals to ZL minus Z0 divided by ZL plus Z0. Right? Now what is the equation of S? S is equals to 1 plus magnitude of gamma divided by 1 minus magnitude of gamma. From this one, obtain gamma. Just if you are obtaining gamma from this one, clearly S by 1 I am considering here. So it is S plus 1 divided by S minus 1, a component and dividend will gives you 1 plus magnitude of gamma plus 1 minus magnitude of gamma divided by 1 plus magnitude of gamma minus 1 plus magnitude of gamma, which is equals to, here gamma will be cancelled, 2 divided by 1 will be cancelled, 2 magnitude of gamma. Therefore clearly magnitude of gamma can be written as S minus 1 divided by S plus 1. So whenever we require magnitude of gamma, simply it is S minus 1 divided by S plus 1. Now substitute here. What is the value of S? The value of S is 3. Right? Here it is 3 minus 1 divided by 3 plus 1, which is equals to 0.5. Right? As it is 0.5, magnitude of gamma is 0.5. You can interpret that the gamma may be either positive 0.5 or minus 0.5. If it is positive 0.5, you will get one value of ZL. If it is negative 0.5, you may get another value of ZL. Why will consider these two? For gamma is equals to 0.5. Initially I am considering 0.5 is equals to, what is the formula for gamma? ZL minus, what is Z0? 150 divided by ZL plus 150. Right? So simply easily you can observe that this ZL is equals to 450 ohms. So if you substitute 450 here, 450 minus 150, 300 divided by 600, 0.5. This is the positive value that what we will get if you are considering 0.5. And if you are considering gamma is equals to minus 0.5, then minus 0.5 is equals to ZL minus 150 divided by ZL plus 150, that ZL is equals to 50 ohms. So 50 minus 150 is minus 100 divided by 200 is minus 0.5. So purely you may get either 450 ohms or 50 ohms. So most of you may do a simple mistake, you will consider only positive value. But clearly remember that this is the magnitude what we are considering for the calculation of S. Since it is magnitude, that may be either positive or negative. So most of you may think only it is positive value and you will get with this answer, but this is also the possible value of ZL, that option A and B, so both A and B, that is given in option C, that is right answer. Right? This is a simple problem that what we have using our ZL, Z0, gamma and S. Problem 3. Which of the following statement is not correct for a transmission line? Here he is asking which of the following statement is not correct for a transmission line. Option A, attenuation constant of a lossless line is always 0. Option B, characteristic impedance of both lossless and distortionless line is real. Option C, attenuation constant of a distortionless line is always 0. And option D is both A and C. Here there are 4 statements are given to us. Among those 4 we are supposed to identify the wrong statement or which is not correct. Right? Observe the statements which are given to us. The attenuation constant is 0 for a lossless line. Obviously alpha is equals to 0 for a lossless line. That's why it is called as a lossless line. And what is the condition for a lossless line? R is equals to 0, G is equals to 0. If you substitute them, obviously you will get alpha is equals to 0. So this one is the correct option. Right? Next, Z0 is real for both lossless and distortionless line. What is the formula for Z0? Z0 is equals to root L by C for both lossless line as well as our distortionless line. L is real, C is real, so what you will get is a real quantity. The characteristic impedance of our lossless line or distortionless line is always a real quantity. So this is also true, right? And the third one, alpha is equals to 0, that is nothing but attenuation constant is 0 for a distortionless line. Now observe this one, for a lossless line alpha is equals to 0, but for a distortionless line it need not be 0, and something you will get a constant, that's why this is not equals to 0 for a distortionless line, right? So this is not correct. Option A and C both are not correct. This is correct and this is not correct. And what he asked is, he asked to identify the wrong statement, that among these four, option C is the wrong statement. So here you are supposed to identify the answer as option C. As this is the wrong one, option C is the correct answer. A transmission line has a characteristic impedance of 50 ohm and a resistance of 0.1 ohm per meter. If the line is distortionless, attenuation constant is, options are given as 500 Napier per meter, option B is 5 Napier per meter, option C is 0.014 Napier per meter, and option D is 0.002 Napier per meter. Now observe the solution. So this is the data which is given to us. The characteristic impedance of the transmission line is 50 ohms, R is equals to 0.1 ohm per meter, and alpha is asked, and the type of line is distortionless line. For the distortionless line, just recap all the equations that what we have. What is the equation for Z0 for a distortionless line? Z0 is equals to just root L by C. Prior to that, go to the condition for distortionless line. What is the condition for distortionless line? R by L is equals to G by C. From this one you can write L by C is equals to R by G, right? So whenever there is L by C, you can replace that one with R by G. So this can be written as square root of R by G. So Z0 is obtained, R we have. Now what is the formula for alpha for a distortionless line? So the formula for alpha for a distortionless line we require. What is the formula for alpha? For that, consider gamma. Gamma is equals to square root of, what is that major formula? R plus J omega L into G plus J omega C. R plus J omega L into G plus J omega C is the general formula that what we have. Now I am trying to modify this particular equation. R by L, G by C, I will consider here. Then directly I am writing this one as R by L plus J omega, which comes from the square root, and the term which is left for us is just root LC, which is equals to R by L root LC. This is the term that what we have as our real part. I am ignoring the imaginary part as we require only alpha. This is our alpha. So which is equals to R root C by L, right? Root C by L can be written as, here that the root C by L can be written as root G by R, which is equals to R root G by R. Now simply it is equals to root R G. So once or twice if you practice it, it is very easy to remember also. So alpha is equals to, just up to this part I gave gamma, after this one this is alpha. Alpha is equals to root RG. Z0 is equals to root R by G, alpha is equals to root RG. Now multiply them. Just Z0 into alpha I want. Z0 into alpha, which is equals to root R by G multiplied with root RG. GG will be cancelled, so just you will get R, right? So Z0 into alpha is equals to R, Z0 into alpha is equals to R, we require alpha, therefore alpha is equals to R by Z0. What is R here? R is simply 0.1 divided by Z0 is 50. So simply it is 0.002 Napier per meter. So this is the answer that what we have. Simply what you are supposed to do is take the equation that what we have and modify them. Nothing more than that. Just if you are unable to remember these all these conditions, just you remember the basic condition and basic formula, from that one modify it, but you need to do that one with a little bit more speed. So this is the solution for this particular problem.